Hi everyone. Today we will be discussing about trigonometric identities. Trigonometric identities are the basic essential part of trigonometry. So we will be studying about the basic three trigonometric identities, how it is proved, and some problems. So let's start. So what is trigonometric identity? The equations that involving the trigonometric ratios of an angle is called trigonometric identity. Here we will be discussing three trigonometric identities. Before that, we know what is trigonometric ratios. We are familiar with that. Sine of an angle. That means according to for considering a right angle triangle, the sine of an angle is the opposite side by hypotenuse, right? So similarly, sine, cos, tan, cotan. They are trigonometric ratios. So the equations that connecting these trigonometric ratios. The equations involving the trigonometric ratios of an angle is called as trigonometric identity. So these are first we will be discussing the basic three trigonometric identities. First one is cos square a plus sine square a equal to 1. Next one is 1 plus tan square a is equal to sec square a. And the third one is, and that is cot square a plus 1 is equal to cosec square a. So we will be seeing its proof. So the first one, cos square a plus sine square a is equal to 1. Its proof. For that, as usual, we are taking a right angled triangle here. Let ABC be the right angled triangle where B is right angled. And here we will be considering the angle A. This angle A is being considered. So according to this, the trigonometric ratios are determined. So according to the famous Pythagoras theorem for a right angled triangle, we have AB square plus BC square is equal to AC square. This is a famous Pythagoras theorem. Now, the next step, we will be dividing this Pythagoras theorem by AC square. So, let's see what it happened. Now, AB square by AC square plus BC square by AC square is equal to AC square by AC square. So, now we have the square on numerator and denominator for every function. So we will be taking the square outside for from each and every one. That is AB by AC whole square. From numerator and denominator we have taken the square outside. AB by AC whole square plus similarly BC by AC whole square is equal to AC by AC whole square. Now what is AB by AC? According to this angle AB by AC is adjacent side by hypotenuse. What is adjacent side by hypotenuse? That is cos square. That is cos. Adjacent side by hypotenuse of an angle is always cos. The next one is BC by AC. What is BC? BC is the opposite side. AC is the hypotenuse. So BC by AC is opposite side by hypotenuse. So for a particular angle, the opposite side by hypotenuse is sine. Now AC by AC and AC is cut because numerator and denominator is having same. So they are cut. Then what we will get? Cos, and there is a square here. Then cos square A plus sine square. Here there is a square, so sine square A is equal to 1. 1 square is always 1. So we have the first identity, that is cos square A plus sine square A is equal to 1. And this is true for every condition when 0 degree is less than or equal to A, which is less than or equal to 90 degree. This condition is true for this. Similarly, we will be proving the next one. What is the next one? That is 1 plus tan square A is equal to sec square A. In the same way, we are taking the right angle triangle and we are considering angle A. For a right angled triangle, we have AB square plus BC square by AC is equal to AC square. Divide now. In here we will be dividing each and every equation by AB. This is AB square. So the Pythagoras theorem is divided by AB square. So let's see what happens. Then here AB square by AB square. Then the next one, BC square by AB square is equal to AC square by AB square. Now AB square by AB square, we have taken the square outside. Then we will get AB by AB. Then AB and AB are cut because numerator and denominator are having same. Now BC by AB. What is BC? BC is the opposite side and AB is the adjacent side. This is AB, right? So this is opposite side by adjacent side is tan of an angle. Then AC by AB. AC is the hypotenuse. AC is the hypotenuse, and then AB is the adjacent side. Hypotenuse by adjacent side. This is always sec. So we will be having the equation 1 plus tan square A is equal to sec square A. So this condition is true in case 0 degree less than or equal to A, which is less than 90 degree. So here there is no equal to. Why? Because the tan and sec are not defined at 90 degree. If you look at the table about the trigonometric ratio, at 90 degree the tan and sec are never defined. So this is true. This condition is true only for 0 degree less than or equal to A, which is less than 90 degree. And the third identity is we will be proving. Then what is the third identity? Cot square A plus 1 is equal to cosec square A. So here we will be considering a right angle triangle, right angled at B, and we are using the same Pythagoras theorem. Here we will be dividing each and every terms by BC square. In Pythagoras theorem, the each and every terms is divided by BC square. So we will check what happens. Then AB square by BC square. AB square by BC square. BC square by BC square is equal to AC square by BC square. So first one, AB by BC. What is AB by BC? AB is the adjacent side and BC is the hypotenuse. So what is that? Cot, right? Adjacent side by hypotenuse is always cot. Next, BC by BC. Both are cut. Numerator and denominator cut. And the third one, AC by BC. What is AC? AC is the hypotenuse. Then BC is the opposite side. Then hypotenuse by opposite side. Hypotenuse by opposite side is cosec. So this is cosec. So the equation becomes cot square plus 1 is equal to cosec square A. And this equation, that is this identity, is true for 0 degree less than A less than or equal to 90 degree. Here we are not using equal to because at 0 degree cot and cosec both are not defined. So it is excluded. So 0 degree less than A less than or equal to 90 degree. So I hope you got it. We have done with the proof. Now we will be discussing about problem. So first question. Express the ratio cos A, tan A and sec A in terms of sin A. So first, what is cos? Cos A, tan A, sec A should be expressed in the form of sin A. So first we will be using our basic, the first identity we have studied. What is that? Cos square A plus sin square A is equal to 1. So we have here cos here. Now we will be keeping the cos at the left side and taking the sin into the right side. So cos square A is equal to 1 minus sin square A. So it means what is cos A? Then what will be the cos A? That is cos A is equal to root of 1 minus sin square A. That is the so cos, this term cos is represented in the form in the sin with the sin term, right? So cos A is equal to root 1 minus sin square A. Now the next one, tan A. Tan A is equal to sin A by cos A. That is sin A by root 1 minus sin square A. Why you are using that? Here we have proved that this equation, let the equation be 1. In the equation 1, we have proved that cos A is equal to root 1 minus sin square A. So tan A is, we are familiar, we know that sin A is by cos A. Tan A is always sin A by cos A. Yeah, numerator is having sin term and the denominator, the cos, is converted into the sin term that we have converted in our previous problem. So it is cos A is represented as cos A is converted into root 1 minus sin square A. So tan A is represented as sin A divided by root 1 minus sin square A. The third one, sec. What is sec? Sec, we always know sec is equal to 1 by cos A. 1 by cos A. What is cos A? Yeah, we have to know what is cos A. Cos A is always root 1 minus sin square A. So sec is simply represented in the terms, and sec is always 1 by root 1 minus sin square A. So this is proved. Now we will be checking another problem. Prove that cot A minus cos A by cot A plus cos A is equal to cosec A minus 1 cosec A plus 1. So to prove, let this be LHS. We will be evaluating this LHS. So we have cos A and cos A. So before proving the problem, if it is in cos or sine, we should convert it into the least. At the first, we should convert the term into the term of cos or sine. The equation to the LHS side here, with the LHS side we have cos, so it will be converted into the term of cos or sine. So we have cot here. Cot can be converted into cos and sine. How? Cot A is always equal to cot A is equal to cos by sine. Cot A is cos by sine. Now cot A is converted into cos A by sine A. Similarly, this cot A is also converted into cos A by sine A. Cos A by sine A minus cos A is equal to cos A by sine A plus cos A. This we haven't touched. In the next step, we will be having cos A here, cos A here, cos A here, cos A here. So from numerator, we will be taking cos A outside, and similarly from denominator also we will be taking cos A outside. That is cos A into 1 by, the remaining thing is 1. 1 by sin A minus 1 whole divided by cos A into 1 by sin A plus 1. Now we are having numerator and denominator cos A. So we will be cutting both one. So the equation becomes 1 by sin A minus 1 divided by 1 by sin A plus 1. What is that? That is cosec A. That is equal to cosec A minus 1. 1 by sin A. 1 by sin is always cosec. 1 by sin is always cosec. So 1 by sin is replaced by cosec. Another problem. Find ck plus tan A into 1 minus sin A. So ck, here we have in the form of sine. So we will be converting both sec and tan A in terms of sine or cos. Let's see. What is ck? We know that ck is 1 by cos A. Similarly, what is tan A? Tan A is sine by cos. Sin A by cos A. So converting the ck plus tan A into in terms of sine and cos, that is 1 by cos A plus sin A by cos A. This is untouched. The same thing is repeating here, 1 into 1 minus sin A. The next step we have cos A. Here cos A is there, here cos A is there. Both are having the same denominator. So we can write the equation like 1 plus sin A by cos A into 1 minus sin A. Then what is 1 plus sin a? We have here 1 plus sin a in the numerator. We have here a multiplication in between and cos a in the denominator and 1 minus sin a in another denominator. So it can be written as 1 plus sin a into 1 minus sin a. So 1 plus sin a by 1 into 1 minus sin a. What is 1 plus sin a into 1 minus sin a? That is in the form a plus b into a minus b. We have studied this in algebraic equation. We have studied what is a plus b into a minus b. That is a square minus b square. A square minus b square. So 1 plus sin a into 1 minus sin a is 1 square. Here a is 1 and b is sin a. So a plus b into a minus b, a is 1. So 1 square minus sin, b is sin a. So sin square a divided by cos a. What is 1 square minus sin square a? We have studied the first identity, that is 1 square minus sin square a is always is equal to cos square a. It is in the identity cos square a plus sin square is equal to 1. Keeping the cos square there and taking the sin square up in the right hand side, we will get cos square a is equal to 1 square minus sin square a, right? So this is 1 square minus sin square a is equal to cos square a. Here we have square and here we don't have square, so we will be cutting the both term and we will be having the remaining only cos a. You got it? So we have proved the three. We have find solution for this equation. We have proved the three identities. So I hope you got it. Thank you.